Hi everyone. So the goal of this video is to understand forces. So I want you to be able to define what is a force, list and differentiate the different types of forces, and explain the factors that determine a force. All right, so this is a little quick preview. Your notes will kind of look like this. We'll focus on non-contact forces and contact forces. All right, so what is a force? Not what you might see in sci-fi movies like Star Wars. It's a push or a pull. That's a simple definition. Anything that is pushing or pulling is applying a force. Force is a vector quantity. It has a direction. So we need to be able to specify which direction is the force moving. The symbol for force is F, capital F, and there's going to be some caveats to that. For example, I might use something that looks like this. I might say F for some kind of force, but if I'm talking about the gravitational force, I might put a lowercase g right next to there. Or if I'm talking about another force, let's say I'm talking about a force where I am applying a force, I am pushing on something. I might call that F of A. So this is my applied force. This is my gravitational force. So we use a capital F, and then we might use a little letter here to specify what type of force are we talking about. All right. The units for force are newtons, and that comes from a famous scientist named Isaac Newton. So many years ago, Isaac Newton came up with these three laws of motion. And one of the most important laws of motion is this idea of force and how it's related to the mass and the acceleration of an object. All right, so here are some types of forces. The major types that we'll focus on, or the way that we'll look at it, is non-contact forces and contact forces. So non-contact means that you don't need to be touching it. So let's look at those major forces. So we have gravity. So objects with mass are attracted to each other. You can kind of see this picture here where any person on Earth is going to be attracted to the center of the Earth because the Earth has so much mass and objects with mass are attracted to each other. Um, this is true for our solar system and many objects really, but the more mass an object has, the easier it is to see that it has a gravitational force. And it really comes down to how much mass do the two objects have and how far apart are they. So it really comes down to the two masses and then how far apart are they. If they're closer together, they have a stronger gravity. And if the masses are bigger, then there's a stronger gravity. So the force of gravity comes down to these variables here, how far they are and the mass of the two objects. Some other forces that you'll hear about are electrical forces. So I'm sure you guys are familiar with electrical forces. If you've ever touched something that had static electricity, you might get shocked. Or if you ever rub a balloon against your head and you might have your hair kind of stick up, that's from electrical force. And it really comes down to whether or not the particles have the same charge and they might repel each other, or if they have a similar charge, they'll be attracted to each other. But that comes down to how strong of a charge do you have and how far apart are those two charges. One thing I want to point out real quick is notice how similar this equation is to the gravity equation. There's some kind of constant in the front. There's two similar objects, and then in the denominator we have how far apart are the objects. So two very similar equations, but two very different forces. And then the last one is the magnetic force. So these lines here represent what we call field lines, where there's a force between these two objects. So we might know that a north and a south magnet are attracted to each other. So we have arrows going from north to south. Like there's some attraction there. But the lines will even kind of go around, and this is what we call magnetic field lines. So this is how a magnetic field might be created to kind of push magnetic objects that are maybe near a magnet. But again, these are all things that don't require physical contact. Now let's compare that to a few contact forces. There's applied force, which is just the force that is being exerted by somebody. Somebody is pushing or something is pushing on an object. So in this little simple picture here, we have a person pushing a fridge and their applied force is going in this direction. Now, oftentimes in our everyday life, we experience friction. So friction is a force that resists the applied force. You can see it's going in the opposite direction of this person's applied force. And it just comes from two objects rubbing together. More specifically, it might come down to like how rough the surfaces are. So if you were trying to slide something over ice, well, ice is really smooth, so there would be very little friction. And oftentimes that's a problem when we're trying to walk on the ice in the wintertime. If there's no friction, our shoes will just slip. On the other hand, if you tried to rub something over sandpaper, that's a really rough surface, and there's going to be a lot of friction. It's not going to be very easy to slide that object. All right, and then another contact force is air resistance. Now, air resistance is a contact force because you have air molecules that are like pushing up against you, or in this case, this little picture here, the air molecules are hitting the inside of their parachute. So gravity is pulling them down, but there's air molecules that are hitting this person and hitting the inside of the parachute that are kind of slowing this person down. So it's a resistance force. All right, and then a couple more we'll talk about are a spring force and tension. So a spring force is from a spring that's either being stretched or compressed. And it really comes down to two things. It comes down to how stiff is the spring, what we might call the spring constant, and then how much did you actually extend or compress the spring. The further you stretch it, the more force will be in the spring. And so it's a pretty simple equation. It just comes down to the spring constant, how stiff is the spring, and how far did you stretch it. And that really determines the force that a spring has. And then tension is a force in some kind of rope or string or something that is like holding something up. Maybe it's hanging from a ceiling, but there's some tension holding something up from the ceiling. Or it could also be tension in a rope. Maybe during tug of war, that rope is experiencing tension. And so that's another force that we might feel as we are playing tug of war. So that's another contact force. Okay, so those are the basic forces. One thing a more advanced idea is trying to compare how are these forces related to each other. For example, maybe go back and watch that part where I talked about how the gravity force is similar to the electrical force in terms of the equation and how those equations are related to each other. Or maybe think about how some of these forces might be seen at the same time. For example, the applied force and the frictional force, and how similar frictional force is to air resistance, right? Both of those forces are resisting motion. So try to put all those pieces together and see how some of these forces are related. And then the next topic will be about how we calculate forces. All right, good luck.